Hey, sixth graders. Today, we're diving into something really exciting in math. Patterns from tables. Think of these patterns as top secret codes that you get to crack. Mathematicians love finding patterns because they help us predict what comes next and understand how numbers relate to each other. I'm going to be showing you some examples of input-output tables in this lesson. Remember, an input-output table is like a special code machine. You put a number in, the input, and follow a specific rule, you get a different number come out. That's the output. By looking at several inputs and outputs, you can figure out the secret rule that connects them. Let's look at our first example. In this input-output table, we can see that the input pattern rule is that it starts at the number 1 and increases by 1 each time. The output pattern rule is showing that it starts at 1 and increases by 3 each time. Now, let's think of these tables as machines with operations. These machines take your input and do something to it and give you an output. You want to think about what operation or operations are being done to find the output. In this example, the input starts at 1 and increases by 1 each time up to the number 5. The output starts at 1 and increases by 4 each time up to the number 17. That pattern of increasing by 4 is a clue about what the machine might be doing. But it's not the complete clue. To find the full rule, we need to think about what operations could change each input into its corresponding output. Looking closely, we could try multiplying each input by 4, but that doesn't quite work. We need to do a second operation. And in this case, we know that the input of 1 multiplied by 4 equals 4. In order to find the output or get the output of 1, we would also have to subtract 3. All right, now we have our two operations. Our first operation would be to multiply by 4 and then subtract 3. All right, let's move on. With this table, we could also extend it. And if I wanted to extend it by 3 more rows, I could follow my input rule and my output rule. And of course, I could use the pattern rule that relates the input to output. In this case, I know that my input pattern rule is to increase by 1 each time. My output pattern rule is to increase by 4 each time. So the next 3 inputs in my chart will be 6, 7, and 8. And my next 3 outputs will be 21, 25, and 29. We know that with an input of 8, multiplying that by 4 will equal 32. 32 subtract 3 will equal 29. And that's a way we can double check our work, having an output of 29. All right, let's move on. It's time for some practice. Here is your first problem. Identify what one operation is done to the input to get the output. I've provided an input-output table for you. Be sure to think of our input rule, our output rule, and the pattern rule for relating the input to output. And in this case, you only need to do one operation. Pause the video and try this on your own. Okay, ready for the answer? The operation is to multiply by the number 7. If our input is 1, 1 times 7 will have an output of 7. 2 times 7 will give you an output of 14. And so on. If you had it, Great job. Let's move on to the next question. Write the next 4 input and output numbers for the continuation of the table in question 1. Pause the video now and try it out. Welcome back. The next inputs would be 5, 6, 7, and 8. Using our input to output pattern rule, which is to multiply by 7, the outputs would be 35, 42, 49, and 56. Question number 3. Find 2 operations to do to the input to get the output. There are 2 operations needed for this one. Pause the video and try to figure them out. The answer is multiply by 3, then subtract 1. Question number 4. What would the output be if the input is 10? Using the table from question 3, where the rule is multiply by 3, then subtract 1 to relate the input to output, try and figure it out. Pause the video now and rejoin when you're ready. Okay, welcome back. If you had 10 times 3 equaling 30 and then subtracting 1 to get 29 as your output, you are correct. If the input is 10, the output is 29. That's all for now. Great job cracking these mathematical codes. Remember, finding patterns in tables helps us understand relationships between numbers and make predictions. We'll explore more exciting math concepts next time. Until then, keep looking for patterns everywhere.